Hi viewers, the last minute professor is back. How to find whether a given number is prime or composite. Composite numbers are divisible by numbers other than 1 and itself, whereas prime numbers are not divisible by any number other than 1 and itself. Prime number is a number divisible only by 1 and itself. In other words, for any number n in the range from 2 to n minus 1, if there are any divisors, then it is not a prime number. What could be the minimum divisor and the maximum divisor in the range 2 to n minus 1? If you have a number n, the least possible divisor could be 2. In that case, n can be rewritten as 2 into half of n. So the greatest possible divisor would be half of n. Therefore, instead of checking for divisors from 2 to n minus 1, it is enough to check from 2 to half the number. For example, consider the number 16. Other than 1 and 16, the possible divisors ranges from 2 to 8. Even if any one divisor is found in this range, we can say it is not a prime number. Let us see the pseudocode. Let n be the user input. Since we have to check if there are any divisors in the range from 2 to half the number, I'm using a variable I to track it. I have initialized I to 2 and I repeatedly check if there are any divisors till half the number. That's the reason the condition in while is I less than or equal to n by 2. Note that if the user input is an odd number, n by 2 will be in decimal. In that case, we can ignore the decimal value and just consider the quotient. To indicate that, floor division can be used. So that is why I have mentioned it here by double slash. I have incremented I at the end of the loop. Now that the range is being tracked by the variable I, if I completely divides the number, leaving zero remainder, it is a divisor. To track whether there is a divisor or not, I'm using a variable flag. I have initialized it to 1. If I find a divisor, I shall update the flag to 0 and exit the loop because even if one divisor is found, the user input is not prime. Therefore, after the loop, if the flag is still holding the value 1, it indicates that no divisors are found in that suspected range and so that number is a prime number. Else, print it is not a prime number. Let us see an example for this. Consider n is equal to 15. So we are initializing I to 2 and flag to 1. Now we have to check if the value of I is less than or equal to n by 2. That is half the number. So here the value considered is an odd number. 15 is odd. So if we are dividing it by 2, we'd be actually getting 7.5. We need not bother about that 0.5, that decimal part. We can just chop it off. So we are using floor and we can check till 7. That would be sufficient. So now 2 less than or equal to 7. Yes. So now 15 modular division 2, that is when we are dividing 15 by 2, is the remainder 0? No, the remainder is actually 1. So the statements inside the if gets skipped and the line after if gets executed. Increment I by 1. So I value becomes 3. Again, the control passes here. The condition is again checked. It is true. And again, when you're coming inside, 15 is divisible by 3. When you're dividing 15 by 3, the remainder is 0. So what you are supposed to do, set flag to 0 and break, that is exit the loop. When you're coming out of the loop, here you check whether the value of flag is 1. No, here the value of flag is 0. So else part will get executed and it will print not prime. Let us consider another example. N is equal to 5. So now you're initializing I to 2 and flag to 1. Similarly, if you're checking, so for 5 is not divisible by 2. So I value gets now incremented to 3. Now here this condition becomes false. 3 less than or equal to 2 becomes false. So the control passes over here. What is the value of flag now? It is still 1. So it is a prime number. That's it. To encourage and support this work, do like, share and subscribe. Thank you for watching.